Okay, I've got two trains traveling towards each other. This is a lot like the movie Unstoppable. If you got to see that movie, it's a great movie. A railroad switch operator has discovered that two trains are headed towards each other on the same track. Currently, the trains are 53 miles apart. So let me get this all drawn in here. So I'll put my track in here. Okay, so my track doesn't line up real well. Put my train on my track here. Train on my track. And this train's not so bad for being on the track. Okay, so the trains are traveling on the track, and they are 53 miles apart. So the distance from here to here is 53 miles. Okay. They are headed towards each other. One train is traveling at 75 miles per hour, and the other train is traveling at 40 miles per hour. So let's make this one the 75 miles per hour, and this one will be the 40 miles per hour. Okay. The faster train will require 5 miles to stop. So somewhere in the middle we're going to crash. This one needs 5 miles. And the slower train requires 3 miles to stop. So this one requires 3 miles. About how many minutes does the operator have to warn the train engineers to stop their trains, to start that braking process? Okay, well, we know that in total we're 53 miles apart, and if we take out these 8 miles, the 3 miles plus the 5 miles, so 53 minus the 8, so 53 minus 8, that would be 4, that's 13, so that's 5. So we've got 45 miles of warning time total, right? So let's start filling our information into our table. Again, all these distance, rate, time problems, I always have a distance, rate, time table going. So one train is traveling at 75 miles an hour. 75 miles per hour is a rate, 75, and we're at miles per hour. And the other train is traveling at 40 miles per hour. They are both traveling for the same amount of time. And so their distance, the distance of train 1 would be 75 times t, and the distance for train 2 would be 40 times t. And we know the total distance can't be more than this 45 miles, or they're going to crash. So we know that the total distance is 75t plus the 40t can't be any more than that 45 miles. And see how well the picture helps us set this up so we can figure out the whole situation. Without the picture, I'd be pretty lost here. So picture is very important for our distance, rate, time problems. Then I can start solving the problem. So 75 plus 40. So 75 plus 40 is going to be 115. So we've got 115t is equal to 45. Okay, then to get t by itself, I'm going to be dividing both sides by the 115. So I divide this side by 115, and I divide this side by 115. And so I get t is equal to, let's grab 45 divided by 115. And I actually get approximately, remember these are approximate values because we are rounding, and it's going to be 0.391, so I'll just round it to 39. Well, what does that mean? What are we dealing with? Well, the distance was in miles, right? And the rate is in miles per hour, so that means our time must be in hours. So this is 0.39 hours, which really doesn't make much sense. So let's change it to minutes. So I'm going to take the 0.39, I'm going to multiply it by 60 because there's 60 minutes in an hour, and I get approximately 23 minutes. So the train operator would have approximately 23 minutes to get a hold of both of the engine operators, our engineers, and get these trains to stop. Otherwise, we're going to have a crash. So 23 minutes total is our answer here.